But I do want to talk a little bit about spontaneous reporting systems. Who is already familiar with spontaneous reporting? I know some of you will be. Hands up if you know anything about spontaneous reporting. Not so many of you. Okay. Well, welcome. Come on in. So spontaneous reporting, I think the first system was in fact launched in the UK in 1964. Now, do you remember what year the thalidomide disaster was?
61.
Yeah, 1961. So even with that massive disaster, it took 3 years to put in place the process and the governing bodies to make sure we could prevent the next thalidomide. I think that's not great that it took 3 years, but still, this is what happened. Spontaneous reporting is all about collecting individual case reports of suspected adverse drug reactions. And these reports can be made by a health professional, they can be made by patients themselves, they can come from pharmacists, basically anybody who's involved with the care of a patient who sees a potential adverse drug reaction can report that adverse reaction. And they'll report it either to the drug company who makes the drug or to the regulatory authority in their country. And each country will have its own system where they try to make it widely known to the population that this process is available. Okay. And it acts as an early warning system for potential drug problems. One thing to think about is the concept of causality. So in a spontaneous reporting system, we're asking people to make a personal decision about what happened to somebody after they received a medication and then a harmful event happened. Because we only want people to tell us about it if they suspect that there's a causal relationship and that the medication itself caused the harmful event. So philosophically, causality is actually a really tricky subject, but we're simply asking people for them to make this decision about whether or not this was causal. It means that we then have a very large quantity of these individual reports where for each of them somebody suspected that there was a causal relationship. This may not always be correct. That sort of doesn't matter. What matters is that somebody thought that there was a causal relationship. Now, it's possible that we can look at individual case reports themselves to try to make an assessment of maybe a group of cases, but it isn't practical for us to assess all individual spontaneous reports. And my next slide illustrates this. So although you can't really see the numbers, this is over the last 10 years, the number of spontaneous reports received by the United States FDA. So this is their drug regulatory authority. And back in 2009, they had around 500,000 reports a year. Okay? Last year, they had just over 2.2 million individual reports. Now, nobody can read all of those and make sense of them. It's just not possible. You may be able to take a small group of them and try to make sense of them, but how would you know which ones to even start on? Well, over the last 20 years or so, we've developed some methodologies to try to use these data to help us to figure out what may be genuine problems with medications. There are different views on how useful spontaneous reports are. I believe that they genuinely are the best early warning system that we have for generating hypotheses or signals of potential problems. And people have tried various methodologies to try to make sense of them. We can calculate a reporting rate. So we can count how many reports of a reaction have been made, and estimate how many people have been exposed to the treatment. Now, this is quite difficult to do and can be very difficult to interpret what the numbers mean, because we will never know the precise number of adverse reactions that have really happened. And it's also surprisingly difficult to measure within a given population how many people have received a treatment. So reporting rates, not that useful in my opinion. More recently, methods of disproportionality have been developed, which look like they are more useful. And this next slide briefly explains what we mean by disproportionality. So the idea is that within a database, we store all of the adverse reactions for every drug available within a country or a region. So it's going to have a lot of data in it. If we find that for the drug that we're interested in, drug A, that 12% of all reports received for that drug are for, say, liver failure. Okay. What we do is we compare that 12% with the proportion of cases reported for every other drug on the database, and we see what proportion of those are liver failure. So if within our wider database only 4% of cases are for liver failure, the implication is that liver failure is being reported more frequently with drug A than it is with all other treatments. And we would then say, this is something that should worry us. We're not saying it's definitely causal, but we're saying it's a signal or a hypothesis that we then need to test further. One of the great advantages of this methodology is that nobody has to read any individual case report to do it. All we have to do is store the data in such a way that both the drug is recorded and the adverse reaction is recorded. And then these calculations are actually very simple to do. So it's a way of using these very large quantities of data to generate hypotheses. Okay? Okay, so some strengths and weaknesses of the spontaneous reporting systems. One of the nice things, it captures suspicion amongst anybody who's involved with healthcare. So it's capturing that suspicion using people's brain power. Everybody exposed to the treatment, in theory, can be included. So there's no reason why you have to exclude anybody from this data collection process. So it's very broad. Every single exposure or treatment in your country or your region, again, can be included. So it's a very inclusive kind of study. It can be very good for detecting rare adverse reactions. One thing that can be very useful are individual case reports that are published in the medical literature. So often a doctor or some other health professional will see an unusual case and they decide to write it up, a little bit like the example of Dr. McBride in Australia, and they will write this up, send it to a journal, and these are often the first signs we have of a rare adverse reaction. The disadvantages are we can't measure the size of an effect. We can't know how often this reaction is occurring using this process. We have no idea. The rate of the quality of reporting can be quite poor. So for a report to be valid, all it has to have are a patient, which can simply mean saying, I had a female patient. That would then become a valid report potentially. We wouldn't know if the patient was 6 months old or 92 years old. Could be either, but it would be a valid report. It also has to have a named drug and a named adverse reaction. And as long as it has those 3 pieces of information, it's a valid report. So very, very sparse data, potentially. It can go into a lot of detail, but it doesn't have to. Okay. Although people are reporting their suspicion that an event is causal, it may in fact not be. We can't know. As I've shown you, we can have very large volumes of reports, and another big problem is that we can have duplicate cases. It could be that a patient reports about their own reaction, their treating physician reports it, and their pharmacist also reports it, and maybe none of them know that the others have reported it, and we may not realise that they all refer to the same patient. So it can be difficult to know whether they're duplicate reports. Okay. But nonetheless, this is still one of the key processes we use to find signals. And I've got a definition here of the word signal in this context. And it's basically reported information that there's a possible causal relationship between an adverse event and a drug. And the important things are that either we didn't know about this combination of drug and event before, or that it was incompletely understood and that there's something new about the relationship that has now become apparent. Typically, we'd need more than one single report for it to be considered a signal, but depends on the seriousness of the event. So it's quite a broad definition, but I think captures nicely what we would consider to be a drug safety signal.